Lesson 1.5 is about the basic postulates and theorems related to points, lines, and planes. Okay, the first postulate, and postulates, by the way, do not have to be proven. They are assumed truths. They seem intuitively obvious to us. Theorems have to be proved, but theorems are proved using definitions, using postulates, and using previously proved theorems. So anyway, what makes up lines and planes and space? How many points? Okay, like what's the minimum number? Because we know the point is the basic building block. So it turns out that through any 2 points you have a line. So I have to have greater than or equal to 2 points, and I can have a line. And through any 2 points I can put a single line. So to illustrate this, take 2 golf balls and lay them on the floor on opposite sides of the room. There is only one line you could draw between those 2 golf balls if you connected with string. Then go over and take one of the golf balls and lift it up off of the plane of the floor and hold it up over your head. There's still only one line that would connect those 2 golf balls. Okay, as far as planes, a plane is at least 3 non-collinear points. Okay, so at least 3, and the whole thing is they can't be in a line if we want to determine one unique plane. Because if I take 3 points and I put them on a line, like if you line up 3 golf balls on your floor, they are on the plane of your floor, but you could also put a vertical plane through those. But if you mess up the golf balls, so you put them so they're not in a line, then there's only one plane that passes through all 3 of them, and that would be your floor. Okay, then space. Space, 3-dimensional space, is at least 4 or more non-coplanar points. Okay. So why does it have to be 4? Why not 3? Well, take 3 golf balls and lay them on the floor. They're in a plane. Then add a 4th one. If you put it on the floor, we're still only defining that one plane of the floor. So pick up one of the 4 golf balls and hold it over your head. Now, if you want to include all 4 golf balls, you have 3-dimensional space. So this little chart shows the minimum number of points, and in the case of a plane, non-collinear points, and in the place of space, non-coplanar points, you need to determine line, plane, and space. Okay, the next thing, and we're really not going to worry about which of these are postulates and which of these are theorems, because we treat them both the same once we understand them. So anyway, this one is that if I have a plane that has any 2 points in it, and I say I pass a line through that plane, then the plane that contains the 2 points also contains the line. So if 2 points are in a plane, then the line that goes through those points is also contained in the plane. Okay, and suppose we have a line, and then we have a point that's not on the line or in the line. We can pass exactly one plane through that, and that captures all 3. So again, 3 non-collinear points. There's exactly only one plane that passes through those. If I took this point C and I moved it down onto the line, then there would be an infinite number of points, of planes that could pass through that line. So suppose that C is like a golf ball, and A and B are golf balls, 2 golf balls that you lie on your floor. And you take C and you hold it up above the floor, then there's only one plane, like one piece of cardboard, that would pass through point C and through line AB. Whereas if you put the golf ball on the floor, if you put C down on the floor, then you could put an infinite number of planes through A, C, and B. So the point is that if I move the point C, off of line AB, then I have a situation where there's only going to be one plane that captures all 3 points. Okay, and then the last theorem is about intersecting lines, that if I have two lines and I intersect them, so think about taking two yardsticks and holding them up like a big X, intersecting them. It turns out there's only one plane that passes through those two lines. So this is kind of like the sticks on a kite. Okay, once you line the two lines up and you intersect them at a point, then you've actually defined a plane surface that you could lay on top of those two lines. And that's it as far as the basic truths for points, lines, and planes.